All right, so we're going to look at goal 5. Goal 5, you're going to be filling in the blanks. For your answers, again, I'm going to be expecting for you to give me the information and not me give you the information. Then we'll go over our biology assessment examples. And tonight there will be a 1-hour question and answer session from 9 to 10. And tomorrow another 1-hour question and answer session, which I'll be sending you invites via Remind 101. All right, so what are relationships between organisms called? When we look at mutualism, commensalism, and parasitism, what are these relationships called? Symbiosis. Very good. Make sure you have that there. Raise your hand and tell me, what is mutualism? Go ahead, Shania. Both benefit. Give me an example. You.
Bees and flowers.
Bees and flowers. Good. Move that chair out the way a little bit, Verna. So mutualism. Both benefit. Very good. No, I want you to move it this way so that it's not, yeah, right there. Right there, it's good. Because we're going to need it in a moment. All right. Give me an example of commensalism. If one is effect, meaning what? Is it harmed or is it helped? Helped. And the other one is harmed for commensalism? One benefits and the other is unaffected. Give me an example. Wells and barnacles. Good. Parasitism. Kim, give me what parasitism is. One is benefit, the other is harm. Give me an example.
With the caterpillar with the parasites.
The caterpillar and the parasite. Yep, the parasites are benefiting from getting all the nutrients, and the caterpillar is eventually going to die. It's all good. Athlete's foot is another common one that we know about, which is parasitism. Number 9 talks about field ecology techniques. What that means is the things that ecologists use to study the ecosystem. All right? So these are different techniques used to determine the species diversity in a given area. Remember, ecology is the study of organisms ecology is the study of living and non-living things in the ecosystem and how they interact with one another or the relationship between one another. So the techniques used to study this is called an ecological technique or ecology technique. Questions that may pop up on the test will be questions like, identify which of these are an ecology technique. That is testing to see if you know what ecology actually means. All right? This is an example where a diver is using a quadrant to measure organisms on the seafloor. So that's just an example. Abiotic and biotic factors. Biotic vocabulary review is what? Living things or something that was once living. We have bananas that we eat. They're not living anymore, but they were once living. Therefore, it's a biotic factor. Non-living organisms obviously would be abiotic. Things like rocks, sun. Number 12, the number of organisms in an ecosystem that can support in a healthy manner is what? Carrying capacity. This is when we talked about when that little square up there by the front of the thing, we looked at that. All of us, as many of us fit in there as we could. If you did not fit in there, you were on the outside, which meant that you could not fit within the carrying capacity. Things that limited that or limiting factor are things that actually limit the growth of an organism. It can't fit here. Some examples may be light, the amount of sunlight that's available. That's going to limit the amount of plants that's going to grow. It's called a limiting factor. Limiting factors are going to influence carry capacity and growth. You need to put and growth on your paper. You also want to add some of these examples because when we were in our box there, if there were not enough food there, you left and moved to an area where there was food. If it was too much competition for the food that was there, you left and went to an area where there was not a lot of competition. If the weather, whether it's harsh winters or too hot summers, you're going to want to move. Reason why I moved to North Carolina, the winters are too cold for me in New York. So I had to get out of Dodge. All right, let's take a look at our energy flow. Energy flows would be things like food chains and food webs. What is a food chain? Give me your definition.
A diagram that shows what eats what.
Okay, so does a food web.
It shows how energy is passed.
So does a food web. What's the difference between a food web and a food chain? What does a food chain look like?
The food chain shows what and a food chain.
So does a food web.
It's like the linked animals.
What's
How energy is passed.
so does a food web. What's the difference between the two? What do they look like? What is the difference between the look? What do you mean by a chain? Is it all over the place or is it linear? Linear. The food chain is linear. It's only going to show one flow. So the caterpillar eats the flower, the frog eats the caterpillar, the snake eats the frog, the owl eats the snake. One flow of energy. Linear means the one flow. A food web is, however, what? Many whats. A food web is many whats. Does a food web have more than one food chain? Many food chains. And they're all connected together. So it not only shows the one thing that a fox is going to eat, it's going to show the several things. Not only going to show the things that eat the mice, it's going to show several things that eats the mice. It also shows the trophic levels. So here you're going to see producers, consumer 1, consumer 2. You're also going to see decomposers in most cases. Are we good? Something that we've discussed, but we just didn't talk about it as far as calling it an energy pyramid, is the energy pyramid, because we looked at this information about how the energy flows throughout an ecosystem or throughout the food web. So it's just a geometric representation of the food pyramid. Again, what's at the very bottom is the grass, the birds, the bunnies eat the grass, the snakes eat the bunnies, the hawks eat the snakes. The purpose of the shape is to show the amount of useful energy entering each level. The amount of each shape entering each level. Any questions? No? Alrighty. %% rule. This could pop up. It basically tells us that only 10% of the energy from each level is switched to the level above it. So, for instance, if we look at, this is a ecological food pyramid. So if we look at phytoplankton, start off with 1,000 units of energy. Only 10% of that is going to go to the the plankton that eat plants. So only 100 units. For the carnivorous zooplankton, only 10% of the 100 is going to go there, so only 10. And then for the carnivorous fish, only 10% of the 10 is going to go there, so the 1. And then we get to the tuna, which is the highest level in this pyramid. only 0.1 is going to go. Does that make sense? So again, 10% of energy travels from each level or moves up. Where does the heat go? In activity, energy is still also in the feces and the urine, so it goes within the waste as well. If you ever change the baby, you will realize that the poop and the pee is warm or hot. All right, so here is something for you to try. Suppose the trees are providing 10,000 calories to a giraffe. How much energy will be passed to the lion? 1,000, because 1,000 is 10% of the 10,000, right? How much energy was located in the trees?
Oh.
No.
20,000? Okay, let me ask you this. Where did the giraffes get their energy from? The trees. The giraffe got how much percent from the trees? What percent? 10%. So therefore, 10,000 is 10% of what? These are easy numbers. You're just adding a zero. 100,000. Did we not just see this here? A zero just got taken away. So if we only knew
Oh.
what we're looking at here is it says that we're looking at this one. This was the 10,000. This was the giraffe. This was the plant, and this is the lion. So it said 10,000 was at the giraffe. You all told me that 1,000 goes to the lion. So then I asked, what were the plants? You add another zero, it's 100,000. Does that make sense?
Mm-hmm.
That's math, not science, guys. Alrighty. Human population. Our human population is growing like this. But the question asks, what is exponential growth? What does the word exponential mean?
The rate, no, not rate.
This is a mathematical term. What other term do you use in math that sounds like exponential? Exponent. Give me an example of an exponent.
2 squared.
2 squared, which would be 2 to the second power. 4 to the fourth power. When we do that, does the number grow slow or rapidly? Rapidly. So exponential growth is a rapid growth. Is that what this picture shows? Yes, this jump or this spike is exponential growth. So if a question on the exam asks you, describe the growth in a graph like this, that's going to be exponential, not a decline, not a gradual growth. That's an exponential growth. All right? Now, what are some factors? Now, this is something you have to do some critical thinking because it could ask questions like identify some factors or pick the factors that are going to influence human birth rates or influence the death rates over time. What are some things in our society that have influenced the number of births that happen, that influence the fact that we have exponential growth now? This is a common sense question. Why are some reasons that babies are being born more than babies were being born in the past?
Early pregnancy.
Huh?
Early pregnancy.
Okay, you got some early pregnancies. What else? Why? But then we have to think further. Why are people that can have babies earlier in their life than they were before? Back in the olden days, someone had an early pregnancy, possibility that their baby was not going to survive. Why? That's what we're looking at. Why can babies survive now and they weren't able to survive back then? What do we have? Like? We have more food, that we have medicines, we have food, more access to food, different types of food. What else do we have? Huh? More doctors, so we have more technology as well. Back in the olden days, there weren't sonograms. So you couldn't check to see the health of your baby or look at certain things that were going on with the baby, the heart rate. So chances are the baby could be born dead or born with something wrong. All right? What are some reasons why, if the graph went down, why there may be a influenced death rate? What could be some reasons why babies won't survive?
Drugs.
Drugs, medicines.
Vaccines.
What about, don't just, vaccines, what about, don't just think about where we live, think about third world countries.
Disease.
Disease, cleanliness, not so much access to food and nutrients. All right, good. On your paper, I think we are now at number, what? 20? What effect is population size having on food supply? If the population size grows, what happens?
Less food.
Less food. And if the population declines, you're going to have more food. More population, less available water as well. Number 21, what effect is our increasing demand for wood and food doing to our ecosystem? We need more wood because we need more paper, we need more housing, we need more buildings. We need more food because we have more people. What is that doing to our ecosystem? Huh? Ecosystem is our environment. Come on, people. It's taking away resources. This could have possibly been a land, or it was a land, that was forest. What lives in forests? Animals. What happened? They have to move. This could be an ecological succession. And they have to migrate to other areas that maybe they now become prey instead of predator. Or an area where now there's more predator for other prey that's there. The question that you have on here is, have we reached our carrying capacity or have we exceeded it? Basically, what this is doing is just, I'm not going to answer this question for you. That's something you'll have to answer on your own. But basically, the question that's here for you is for you to be able to develop an answer that makes sense. Because it may ask you a question, identify which choice explains why we've reached our carrying capacity. Because some people think we may, some people think that we may not. But the answer has to make sense, and you have to be able to make sense of the answer. Some of you may say, because there's no more space. That would be a valid reason. Some of you may say, we haven't reached because we still have more area to cut down trees. That could be a valid reason. But you have to be able to pick out the choice that makes the most sense. Does that make sense to you? Oh, you're good. Never mind. Over here. All right. All right. 3 factors that are going to affect, these are just 3 that we're going to write down, but there's other things that we've written down as far as, let's talk about those factors. When we were in our little square up there, what were some of the factors that affected the carrying capacity? Thinking about this, why did some of you leave that box? There was not a lot. Okay, one reason was the limited space. That's a factor. You want to put that down. Huh? It couldn't adapt to the environment, meaning what though? There was not a lot of resources. Limited amount of resources. Another reason would be habitat destruction. If the habitat is destroyed, that's going to limit the capacity. Habitat can be destroyed with acid rain. Some of you already also mentioned, and this probably be your third one, is survival. Survival could fall under the category of too many predators or not enough food. That could come from non-native species. So different species may have migrated to your area, and now you're prey instead of predator. Or you migrate to another area and that you become a predator in an area that you are not normally. All right, let's look at climate change. Oh, let me go back to this exotic. Why are exotics a problem? Because they're non-native species. And that falls under, when I said they're non-native species, why is that a problem again? Competition. And non-native species can also eat things because they can, but they probably shouldn't. That may become shelter or protection for another species. So now that's damaged. The ecosystem is damaged. So damaging to the ecosystem. All right, climate change. What are some things that cause climate change? Go ahead, Cam. Global warming. Greenhouse gases. Questions? No? All right, so then let's look at some things that cause climate change. We're going to list them all down, but these are humans. What was I going to say? Next to the area where it says, what are the effects of climate change? I want you to put in parentheses, write the, no, I'm sorry, never mind, I apologize. On number 25, where you put global warming and greenhouse gases, you want to add this information. Humans burning fossil fuels. This is 8th grade and 7th grade review. When we do that, we put CO2, which is carbon dioxide, and we also put methane into the atmosphere, and that's what causes the global warming. Some of the effects. Polar ice caps melting. We got sea levels rising. There's more frequent and violent storms. Tropical diseases. We've seen that recently with Zika virus. That's not something that is in our area or should be in our area. Now that's coming from mosquitoes from another area. And then, of course, loss of habitat. And you all did projects where you did presentations. You had something about the rainforest. You had something about the national parks. There was the coral reefs. All right, looking at the back. Clear cutting for wood is called what? We're cutting down so much wood, so many trees. Deforestation. That's going to result in habitat being lost, species being now eliminated, or they have to migrate. The accumulation of harmful substances as it moves through the food chain. This is called bioaccumulation. Pesticides is an example, moving through the food chain, affecting one organism, which affects the organism that eats, which affects the organism that eats. Same thing with mercury. Sometimes the grocery stores put out, or the news has out things, don't eat any tuna right now. There's high levels of mercury in the water. And it all boils down to us taking care of our earth in a healthy way. What is that called when we take care of something? Starts with an S. You all should have did your homework. Stewardship. Being good stewards, good citizens. And it starts today. We do this so that we can be able to use our natural resources, or the way that we do this is by using our natural resources without depleting them, without overusing them. What is that called? Doing something in a way that we still reserve. Starts with an S. We want to remain this type of economy. We want to remain this type of world. Remaining means to be, oh, y'all killing me. Sustainable, thank you. Questions? No? Good. All right, on your packet you have scientific method. What is the scientific method? Huh? Speak up. Come on, because I want to get to the other one and get through with that. Speak up, Brianna.
6 steps.
Okay, steps that are used to find the what? Steps that are used to do what? Find the answer to a problem. It's exact. This is the area to make the mistake and see if you are right. You want to say it. You want to say it, because if you don't say it, then you're going to always think that you're wrong. And you're like, oh, I should have said that. And then on the test, you're going to get it wrong because you didn't pick what you should have did. So this is the chance to say it out loud. And if you got it right, you're like, oh, okay, good, I know that. If you got it wrong, you're like, okay, then what's the right answer so that I won't get it wrong when I take the test? All right? What are those 6 steps? Question. Okay, let's write that down before we go on. The question is also known as the, starts with the P. It's like in math. Problem. Parentheses, not a question. The question. So the first step is the problem, which is in the form of a question. Next, you do what? Hypothesis, which is a educated guess using research. Educated guess using research. Thirdly, you now what? We can't analyze any data because we haven't done anything.
Oh,
Nope, we already did that. Hypothesis using research. Yes. The procedure is also known as the experiment. And it is steps taken. So the procedure is the experiment where it's steps taken. Then what? For instance, what should I wear to work? Huh? Gather data. Gathering data is charts, words, and numbers. Charts, words, and numbers. Once we've gathered that data, what must we do? Analyze the data, which means interpret it, make sense of it. If we look at charts, we don't know what they mean, then we can't do anything yet. And the very last step, conclusion, which is the what? The final answer backed up with what? which is called what in this steps? What is your evidence in this step? Data. It's the final answer backed up with data.